Hey everybody, it's Dan the Git School Dude once again with another Gitlab CI video. Today we're going to be talking about Gitlab CI's vision, as I call it. You won't find the vision in their documentation anywhere, but this is where I want to talk about how they have designed their Gitlab CI runner and job architecture, how the user defines tests and what the interface is to the user, and some of the things you can and cannot do. So everything we're going to talk about today can be found in the documentation, and if you want, instead of this video, we could just slowly together read the documentation. Oh boy, that sounds fun. Instead of that, we're going to be actually not using a terminal today. I know you guys are upset because you like the Linux terminal. I do too, but today we're going to be talking about concepts, and it's easier to visualize these things through drawings and PowerPoint slides and all that kind of stuff. But before we get over there, I want to show you something I discovered the other day, which is that my Git School Dude Hello test project is a Hello World project in gitlab.com. Has had some activity on it. People are watching the videos, they're learning some stuff. It's pretty cool to see people testing things out and contributing here. So I highly encourage that. It's a great way to learn. So thank you very much for doing that. Okay, let's go ahead and get started here. Okay, we're going to talk about what I call the vision, and this is essentially the architecture of Gitlab CI, how the runners are designed, and how the user interacts with it. So there's a lot of big questions when people are talking about, well, how do I use continuous integration? Which, by the way, if you haven't watched my introduction to Gitlab CI video, please watch that first. We may lose you on some of the terminology and some of the concepts here if you haven't already seen that or are not already familiar with Gitlab CI. So some of the big questions here. When you define a job or a test, what does it do? How do you define that? What if you want to control the platform, the OS that the job runs on? How do I define what the triggers the tests? What if I want to fetch and clean versus clone? What if I have submodules? What does that mean? There's all these big questions, but there's also more technical questions like, well, what machine will the job run on? Where's the workspace, meaning the working directory where the clone will actually exist and the build will take place? What user is going to run this? What permissions do they have? Can I lock jobs to a workspace so that downstream jobs already have the artifacts from an upstream job? These are all great questions, and Gitlab CI has a couple answers. And the biggest one is that most everything is controlled with this hidden .gitlab CI YAML file. That defines what the tests are. You can control which runners your tests run on, what the build triggers are. All these mechanisms like fetch, clone, submodules, all that stuff can be configured using the documentation for what this file can control. But there are other questions that Gitlab CI sort of replies with, well, you want to know what machine your job's running on, or where the workspace is, or the user, the permissions. Gitlab kind of takes a this is none of your business approach, and they do this purposefully, and we're going to talk about the pros and cons of that at the end of this. But before we do that, I just want to show you sort of the layout of how we're going to show these things visually. So the top box is GitLab, as you are aware. GitLab can have multiple projects, and each project can have multiple jobs, and those jobs and what they do can be defined in that YAML file that we just talked about. But the runners themselves are different. They are not part of GitLab. They communicate with GitLab, but they can run on separate machines. In fact, they're supposed to. When I say a machine, I mean a computer. So for example, runner 01 here is running on machine X, and it has some tags associated with it. We're going to talk about what that is. But down here, you can see that this is what I represent the workspace. So this is just a directory structure that the GitLab runner process running on machine X here we'll create directories, clone projects, test things. All of that stuff is happening in these workspaces. And there are, as you can see, there's multiple workspaces because multiple jobs can run per runner. All that stuff is configurable. And here I'm just showing that GitLab may have multiple runners associated with it that run on different machines, and each machine can actually contain more than one runner. So GitLab CI just runs sort of as a service on the machine, and you can define what types of runners you want to run on that machine. It could be one, it could be many. Okay, so the first thing you need to understand is that these jobs that are part of projects in GitLab, they are picked by runners. So there will be a pool of runners typically available to a group in GitLab or just a project. All of that is configurable, but the point here is that the runner itself goes out and it asks, hey, are there any jobs available for me? And if there are, it will pick a job and execute it, and then report that information back to the GitLab pipeline associated with it. So runners can run multiple simultaneous jobs, each getting its own workspace. I already touched on that. So there could be 2 workspaces here. There could be 50. If you have a honking machine, maybe you've set your one runner to be able to run, up to 20 simultaneous jobs. All that stuff is configurable. And these tags that are defined in both the Gitlab CI YAML file and in the configuration of the runner themselves allow you to control which runner can choose which job. So for example, Project A's job A2 has a Python tag, which we assume has been defined on the runner side, which basically means that the runner provides Python on that instance. So if you're going to test something that needs Python, you need a runner that has Python on it. It's very simple. So, tags could be used for, the tools that they provide, like Python, or platform dependencies if you have CentOS 7 or Ubuntu or Windows, what have you. What's interesting about Gitlab CI and what I consider a limitation at this point, now this is the end of 2018, so depending on when you're watching this, this might not be true anymore, but the user cannot control the workspace. It is automatically reused or created if necessary. And what I mean by reused is if the runner has workspaces that are empty from a previous job and it's using the same project, it can reuse a clone that exists. Or when I say created, it will create a new directory under this directory structure to perform the testing and clone the repo into. Okay, so let's consider this simple project. If you've seen my intro to GitLab CI video, you may have seen this file before. It's a very simple build and run configuration. We have 2 stages in our pipeline. The build stage will run before the run stage runs. And in the build stage, we have one job defined called build code. In the script section is actually where you define what it does. So in this case, it just types make at the top level of the directory. And the artifacts here will define the output. So in this case, there's a binary called hello because it's the hello world repo that we just showed in the very beginning of this video. After that, we have the nominal run, which runs in the run stage, and all it does is execute the hello world binary. So this view over here, if you're familiar, this is what it looks like in the merge request section. So what's nice is you have a merge request, you can test exactly the tip of your branch, and you can see these check marks. Did it build, did it run, etc. So we're going to go through this with the previous layout of how GitLab and the runners work to show you actually what's happening when this pipeline starts from start to finish. Okay, so let's pretend this project A is the simple build and run 2-job pipeline that we just described. A pipeline is created when a user pushes to the branch or a tag, or there are several. You can actually start one manually. It's a configurable mechanism, but the point is here, a pipeline will be created when a user performs an action like pushing to the branch, and this will immediately create 2 jobs. Now, the second job can't run, the run job, until the first job is complete, which is defined in this Gitlab CI YAML file here by these stages. So the build code must run before nominal run based on the stage definitions. Okay, so the first job to run is build code. It's now available to be executed, and GitLab will now search for a runner available to this project that can run this job. In this particular case, with no tags that restrict which runners are available, we'll just say, for example, that runner 01 chooses the build code job. So the 01 workspace, which we're going to say, as it, for example, is not currently in use, will be chosen, and runner 01 clones the hello repo from gitlab.com/getschooldude/hello under that directory on machine X. So once this build code job completes, the artifacts from the jobs workspaces workspace are uploaded to GitLab. Now this is one thing that is very unique about GitLab and is cool but has some downsides. So literally what that means is when the build is complete, we have defined here that the hello binary is an artifact that the next job needs, and therefore at the very end of the job it's going to upload the hello binary. Where does it upload it to? The mystery GitLab box. You don't have to worry about it as a user. So because there's only one job in this build stage, the build stage is now complete. The jobs in the run stage are now available to be run, and in that case there's only one job, and that is nominal run. So in case it's not clear here, you can have multiple jobs per stage, and those jobs will run in parallel. So we have nominal run here. Maybe we'd have another job called exceptional run, and if we put it in the stage run like we have here, those runs will execute in parallel, which is pretty cool. So once again, GitLab will determine which runner the nominal run job will get executed on, and that runner will determine its workspace. So let's say, for example, runner 02 picks the job for execution, and the repo is cloned into workspace 2 on machine Y. So we ended up building on machine X, but we're going to run on machine Y in completely different machines and completely different workspaces. So immediately after the clone for this run job, but before the job script section is executed, that's what the job does, the artifacts have to be downloaded to the workspace. This happens automatically through the Gitlab CI artifact mechanism. And so this artifact system essentially means that the second job, the run job, does not need to rebuild the hello binary, and we don't need to lock the workspace for downstream jobs. In fact, there is no way to lock the workspace. So what GitLab CI has done here is created a scalable solution where each job that runs need not worry about the prerequisites, because that is handled for you automatically through artifact uploads and downloads. So in my example where we had 2 runs instead of 1, both could execute in parallel and both would download the hello binary because it needs it as a prerequisite to run in this example. Okay, so here's where the sarcasm starts. If I haven't lost you by now, I realize PowerPoints aren't exactly the most thrilling thing to watch on YouTube. But the GitLab CI vision, some might consider brilliant. I think it's clever, but has some problems. There are some, so I've listed some pros and cons here. One pro that's fantastic is it's really easy to get started adding new tests. I mean, if you watch my introduction to GitLab CI video, you can see that we have gone from absolutely no continuous integration and testing to testing in less than 10 minutes. So on the user, it's very easy to start adding tests. The merge request integration is hard to turn down. Right in a merge request, you can see the status of the tip of that branch and know whether it's stable or not stable. That is supremely useful for software development. Another thing that's clever is what gets tested is actually tracked in your Git repo in this .gitlab CI YAML file. That means that you have a record over time of what was tested and what is considered stable. So when a project first starts, you might not have hardly any tests, but by the end, you might have a whole bunch of tests. And all that information is tracked in the file, and what gets tested can be branch specific because that file is tracked. The solution is extremely scalable because each job runs in an arbitrary workspace to the user, from the user's perspective. If you are running out of runners available for jobs, you can just add more runners from the IT perspective, and all of a sudden the pool has more resources for several projects to use if that's the way that it's configured. Another thing that's cool, but we're not going to get in the details of it in this video, is it supports Docker containerization. This lets the user actually define the platform that they need to build and test and run without needing to create specific runners on those platforms on the physical hardware. Some of the cons, these are the things, I've been thinking about this for a while. There are some things about this architecture that may make you want to stay away. It requires the user to define artifacts job to job, or the trade-off to that being underutilized pipelines. So remember, in our build example, you have to define the binary that the run job needs to run. That's an artifact definition. And if you want to split up your jobs in the way we have in a 2-job stage, you must define that. Now, in our example, it's very simple, but large, complicated projects, just defining the artifacts of what something needs to run might be something nobody's even thought of up until this point. So the trade-off is you don't have to define your artifacts, but that will force you, when I say underutilized pipelines, that will force you to do everything in one job. So imagine we had one job where we build and then immediately run afterwards. Effectively, you'd get the same thing, but you'd only have one checkbox from the at-a-glance view instead of 2. I prefer 2. I want to be able to see at a glance what failed out of the testing that we did. So what this means with the artifacts and the way they've laid this out is that artifacts are continually uploaded and downloaded to workspaces, as we've shown in our previous example. So as you might imagine, what happens when the artifacts are big? I mean, the hello binary is like a couple kilobytes or something, no big deal. But what if your project needed megs or gigs, and then you expand that into parallel workspaces? You could imagine that just the network traffic to move these artifacts around could be a problem. Builds with hard-coded paths can break. So I won't get into the details of this, but let's say your build requires that you point something to a particular path for a library load, for example. Well, if your first job builds on machine X in workspace Y, and then the next downstream job takes artifacts and moves them over to some other workspace, well, the path that you use to build might not exist, and your jobs may break. This actually bit me at work, and it took a long time to track down. So just be aware of that. So you really have to be familiar with how your build works and know that this isn't going to be a problem. Another downside is and maybe this is just me, but in my opinion, the developer might not actually test the same way that Gitlab CI is testing, because nobody, as a developer, builds in their repo, then clones another repo, and then copies some files over to that repo to run. That's just not a thing that happens. So I always try to stay in my recommendations is workflows where the developer and the CI system are doing exactly the same thing. Any deviation from that is a downside from my perspective. Debugging issues can be pretty difficult with this architecture because you don't have a reliable workspace and machine. The workspace and machine is really abstracted away from the user, so it's more of an IT mechanism. So let's say you don't understand why your build works locally but breaks in CI. Well, how are you going to debug that if you can't get to the machine or the workspace consistently where that job is run? Another con that's not really related to the artifact system, but is a significant one in my opinion, is that in GitLab CI, testing the merged state of the branch is not possible before the merge occurs. This means that your development branch, integration branch, whatever you want to call it, can break. The way that this works is in the merge request, when testing happens, it's testing the tip of the source branch. It is not testing the merged state of the source branch merged into the destination branch. That test will happen automatically after the source branch testing passes and is merged, but if your testing process takes hours, your branch could be broken before you actually realize that your branch is broken, if that makes sense. I may make a whole separate video on showing how that could happen, because in words it's a little difficult to describe, but I think it's a major downside that they really need to figure out with respect to GitLab CI's brilliant vision. One last major downside in their design is that stages within stages are not yet supported. And what I mean by that is you can have multiple stages, like a build run or a build stage and a run stage, and things can go parallel within those stages, but the longest poll per stage will mean that downstream actions are waiting on the longest poll. It's a little difficult to describe in words, but in Jenkins, for example, which is another CI tool, stages within stages is supported in a tool called multi-job, which essentially lets you go massively parallel. And I might do a whole nother video on that, but this is a huge downside to me as well with GitLab CI's brilliant vision. So I had this thought when I fully understood how GitLab CI worked, because in my day job, I have a really complex software project with over 100 people contributing, very large artifacts, huge build times. We're talking 5-7 hours. So the implications of using GitLab CI for a project like that are something you really should think about closely before diving in. So this is the final slide. The question that everyone's asking themselves: should I use GitLab CI? The answer is probably yes. If you have a small or medium-sized project, go for it. Some of these downsides that I've described in the cons on the previous slide are not a big deal for small projects. For example, let's say your integration branch actually breaks, but because your CI testing only takes 45 seconds, nobody started new work on that broken state because it quickly reported after the merge of the merge requests that the merge state had failed, and you can easily revert that change. You know, if your build time took 12 hours, that would sort of be a different thing, right? So the bottom line is, if you have large complex projects, you probably still want to use GitLab CI, but you might not want to use it to test everything. I'm a huge fan of this concept of failing early and often on quick tests. So for example, let's say your full testing time takes 7 hours, but you have some quick unit tests that could run in less than a minute. Well, it'd be great to, in GitLab CI tied to your merge request, run those unit tests. If those things fail, you don't want that stuff coming in. So for some of the longer tests, it might make more sense to actually use a more capable tool like Jenkins, where workspaces can be controlled and the merge state can be tested directly. Now, as of me making this video in late 2018, that is the case in my opinion, that Jenkins is a more capable tool, but GitLab CI has a lot of open issues where they're trying to directly address some of these cons that I'm talking about over here. So if you're watching this after 2018, just realize that what I'm telling you here might be complete BS. I don't even know why you watched this. All right, I'm Dan the Git School Dude. I'll see you guys next time. Hey there, YouTube fans. It's Dan the Git School Dude here. If you're like me, sometimes it can be difficult to learn a new concept just from watching a YouTube video. That's why I've decided to create an entire suite of training programs that can be delivered in person or even remotely. This training really takes things to the next level. We're talking PowerPoints, hands-on exercises, jokes to keep people awake, Q&A, the whole 9 yards. If you think your company could benefit from a more formal approach to training, check out continuoustech.net/training to take a look at the training programs we offer. Thanks for watching.